All right, here we go. I want to get a little review video for you. Don't always do this, but I know there's a lot in here and it's spanning over all before break. So remember, everything in this chapter is based off of this idea. All right, you have your parent function. You have your f of x is x squared. It gives you this graph and it gives you this table. Then we use our symmetry to get the other side. So with that being said, the vertex would be here at 0, 0. The axis of symmetry is x equals 0. Those are all the things you need to know. So let's talk about it. We've got 4 different methods. I'm going to walk you through all of them. The first method we learned and talked about, and we keep learning and talking about and doing, is when we talked about vertical translation, shifts up and down, and stretching and shrinking. So if I look at this first problem, what do you know? Well, you know that it's up 5 because of this number here. This tells me it's sliding up 5. Okay? This tells me it's stretch by 2. All right? And it's flipped over this axis. Okay? It's upside down. Negative sign tells me it's flipped. So with all of that being said, how do I graph? Well, I take my normal graph, I slide it up 5, and then I go through my normal relationships. Again, remember, when I start thinking about these, I think about these as relationships, not necessarily coordinate points. So a normal relationship would be 1, 1. I'm going to flip it and stretch 2. So I would go upside down, stretched 2. The next point I would find would be right 2 up 4 from the vertex, right 2 up 4. So I flip it and stretch it. I would go right 2, instead of going up 4, I'm going to go down 8. 1, 2, 3, 4, 5, 6, 7, 8 here. I'm not saying that the coordinate is 4, 8. The coordinate is 2, negative 3. But I went right 2, down 8 to get to that point because I took this relationship, I flipped it and stretched it by 2. I multiplied it by 2. Once you get a couple of points, you can use your symmetry to mirror image them on the other side of the axis of symmetry, not necessarily the y-axis, and sketch your parabola. You need to be able to get some information out of any one of these graphs. Where's the vertex? Vertex is that pivot point. Remember, in this method, this right here is going to give me my vertex, 0, 5. What's the axis of symmetry? Well, the axis of symmetry is always going to come from that point if you can find the vertex first. Or you find the axis of symmetry first and work the other way. Or I look at the graph and see what the middle is. Domain. Domain will always be all reals. Every time. All right? And then the range, however, I go to this number, and that tells me my range number, and then I just need to figure out is it above or below that number. So here it's at positive 5, it's everything below, so my range is less than or equal to positive 5. All right? What if I give you a problem in standard form? So see the difference here? We don't have that X term. If it doesn't have the X term, I can do this. If it has the X term, I'm looking at standard form. When you see standard form, we're going to talk about this a little later, you should try to factor, because factored form is a little easier, quicker to deal with. If it doesn't factor, then you've got a couple of other steps. You need to know the formula. That right there, that gives me the axis of symmetry. You need to know that. Write it down. So in this particular problem, remember, these are A, this is B, this is C, so I would go negative 6 over 3, well, times 2, so that is negative 1 for my axis of symmetry. And like we talked about earlier, these two have a relationship. So if I find the axis of symmetry first, then I'm going to go the other direction. I'm going to take this and plug it in. To work it out. So now I've plugged it in. I know that is my x coordinate for my vertex. My answer here is my y coordinate for my vertex. So there's my vertex, -1, -7. Okay. Domain, all reals, range. I take this number. Is this curve going to go up or going to go down? Yeah, that's a +3, so I know the curve is going up. So then my range is greater than or equal to -7. Okay. And one other thing to note about this is where is the y-intercept? Okay, so if I give it to you here, that is always my y-intercept. Sometimes it's the vertex, it's always the y-intercept, so it crosses right here. This number out here will always be my y-intercept. So if I want to graph this, I have a vertex at -1, -7. I know that point. I know I have a y-intercept at -4, so I know it crosses right here at -4. Okay, so I have a reflection. Here's my axis of symmetry. So I know I have a reflection point over here because I'm 1 away. Now, if I wanted to find more points, I could find more points, but I have enough to graph this. And I know it's going to be, oops, that should be out here a little bit more. Right there. So, this one I worked a little bit backwards. I found the axis of symmetry first, plugged in the axis of symmetry to find my vertex point, used the vertex point to find my range, and then this number right here gave me my y-intercept. Since I know the y-intercept, I can reflect, and then I can find the graph that way. All right? So, a couple more methods to talk about. All right, this is the stuff we talked about this week. Vertex form. It's called vertex form because when I look at the problem, it tells you the vertex. Remember, take the opposite of what's in parentheses and exactly what's outside. So the vertex here would be 2, -8. So I can plot 2, 1, 2, 3, 4, 5, 6, 7, 8. There's my vertex. Okay? So now, I know the axis of symmetry is always this number. Domain is always all reals. The range, am I up above this or am I below this? Well, yeah. So this tells me it's positive, it's curved upward, so it is greater than -8. So now I need a graph, okay? I need a graph somehow. So how can I get a graph out of this? Well, I could use my normal stretch. What I know that this would have a relationship, a stretch of 3. So if I want to graph this from this point, I would go right 1, up 3. If I want to get this point. And then I could go right 2, up, instead of 4, go up 12. So that would get me all the way up here. Then I can reflect those points. Left 1 here, left 2 here. Couple of things of note. Notice in this form, my y-intercept is not this number out here. Okay, it didn't work like that. That's only in those other standard forms does it tell me my y-intercept. Vertex form, it tells me my vertex. Doesn't tell me my y-intercept. I would have to plug it in and do some work. Could I plug it in here? Yeah, you could absolutely plug in here. Plug it in. Say I want to plug in 0 for x to find out y-intercept. -2 squared times 3 minus 8 is going to come out to be but I like using my relationships. That's gonna give me a beautiful parabola. That's what I'm looking. There you go. All right, and then the most recent form we talked about was intercept form. When I look right here, I can tell the intercepts. So I know my x-intercepts are going to be the opposite of what's in parentheses. So the x-intercepts are going to be -3 and +5. Remember, that's not a coordinate, that's two different x-intercepts, okay? So now I need to find the middle of those two. I need to find the axis of symmetry. So I can add them up and divide by 2. 5 plus -3 divided by 2. 5 plus -3 is 2. 2 over 2 is 1. So I know my axis of symmetry is 1. Right here is the middle of my curve. So then I'm going to have to take 1 and plug it back in here. 1 plus 3 is 4. -4 multiply, I get -16. So my vertex is 1, -16. So that would be all the way down here. Then I can make that graph. And I mentioned this a little bit earlier. Sometimes you can factor the graphs that are the equations. If you can factor an equation, I think this method's a lot easier than some of those other methods. You could do the other methods though. I know this is a stretch of 2. I know it's going to shift down 18. I could think like that, absolutely. But if it can factor, I want to try to factor. So this is going to be 2. That's going to factor. So right now with intercept method, I know I've got an intercept at +3. I've got an intercept at -3. So they're equal parts, so I know my axis of symmetry is right there in the middle. And I've already kind of thought about it. I already even talked about those other methods. I know it's shifted down 18. I could do the math, plug in 0 up here. 0 squared, 0 times 2 is still 0, -18. So I have 0, -18 for my vertex. And there you have it. There you are. 4 different methods. We kind of use a little bit of bits and pieces. If you can factor, I think factoring is easier because you get those 2, you find the middle, you find your vertex. To me, this is the easiest method. Vertex form's the second easiest method. And if you don't have one of those 2, then you go to that standard form stuff. Test tomorrow over all of this. Good luck. Ask questions.